Hello everyone, welcome back to my YouTube channel. My name is Sunny Savita and I'm back with another exciting video. So in this video, we'll see that how we can implement a RAG architecture from scratch. Yes guys, so here we are not going to use any framework like llamaindex, langchain or any other framework for implementing RAG architecture. So here in front of you only, I will create the RAG architecture from scratch. So guys, if you will look into my YouTube channel, so there you will find out the different video on top of the generative AI. And here basically I'm creating one playlist on top of the generative AI where I'm trying to cover up different thing, different concept related to the generative AI, and not like a basic one. Okay, I'm trying to cover each and everything in depth. So here if you will look into the video, so you will find out the complete detail related to the topic. Okay, now not even generative AI, I'm thinking to cover NLP, CV, deep learning, machine learning, data science, like every concept of the data science from statistic to machine learning, Python, everything on my YouTube channel, so that you can get each and everything at a single place itself. So yes guys, if you haven't subscribed the channel, then please do subscribe. If this video is adding some value in your learning, then definitely like the video, share the video, and please support the channel, and I will be coming up with many more exciting video in the future. So yes, let's start with the session. Now guys, here first of all let me explain you that what all thing we are going to do in today's session. So each and everything basically I will do inside the Jupyter notebook itself, and for that I'm using the Anaconda. So if you haven't installed the Anaconda guys, please install the Anaconda, and please try to do the setup with respect to this Anaconda. And if you don't know about it, if you don't know about the Anaconda and all, definitely I will create one dedicated video for the end-to-end environment setup. Okay, so end-to-end environment setup for AI development. And yes, I was thinking for that also, but I'm not getting time basically, so I couldn't create. But don't worry, in future whenever I will get time, then definitely I will create one end-to-end video for the end-to-end setup for AI development basically, right? Now here I'm using this Anaconda for what? For my Jupyter notebook. So from here easily I can use my Jupyter notebook. I just need to install the Anaconda, nothing else. So this is my Anaconda guys. Now Anaconda prompt, and from here what I'm going to do, I'm going to launch my Jupyter notebook. So how I can do that? So here I just need to write this Jupyter notebook after installing the Anaconda. So easily you can find out this Anaconda prompt inside your search bar. So once you will search about Anaconda prompt, you will get your Anaconda prompt, and just write the Jupyter notebook there, and your Jupyter notebook will be launched, right? Every time try to launch the Jupyter notebook from the Anaconda itself. Don't try to launch it separately, because here basically you can track like so many things, right? By using the Anaconda itself. Now here if we want to like create a new file, new IPYNB file, then how we can do that? So just click on this new, and then click on this Python 3, then you will get your new notebook. Okay, again I'm repeating, just click on this new, and then you will get and then click on this Python 3 kernel, and then basically you will get your new IPYNB file. So here let me rename the file. So the file name is going to be rag implementation, rag implementation. Okay, rag implementation from scratch, right? So here I can write from scratch. I think this is fine. SCARTCH scratch, right? So I hope it is fine to all of you. Now let's start with the implementation. So one by one, guys, I will try to implement each and everything in front of you only. Now, first of all, guys, let me show you the architecture. So here, basically, I kept the architecture. Now let me copy this architecture, and I'm pasting over here. So let me convert into the markdown, and here is what? Here is my architecture guys. So just wait, I think it is not working. Not an issue. What I can do, I can take a snapshot of the architecture. So just allow me a second, let me take a snapshot of it, right? So here is what guys, here is my complete architecture. Just a second, and yes, now it is perfect. So guys, this is my architecture, and now let's try to implement this architecture from scratch. So here if you will look from here to here, so just focus here. Let me open my epic pen also, and then I can annotate the each and everything over here on top of the architecture itself. Okay, so just a second. Mhm. Okay, perfect. Now what I can do here, I can write that this part, right? This particular part from here to here, right? So this is called data ingestion. This is what? Tell me, this is called data ingestion. In my previous video, I clearly explain you this thing. Then this part, this particular part, this is called a retrieval, right? Till here to here. This one, this is called retrieval. This is called retrieval. Now from here to here, guys, from here to here, this one, the third one, this one, like we are getting the query and we are generating an answer from the LLM. So this is called generation. So this architecture actually I divided into three sections. First is data ingestion, second is retrieval, and the third is generation. Now let's try to implement this particular architecture from scratch without using any framework. And then in the next video, I will show you that how you can do it, how you can do this particular thing by using by using what? By using the Llama index. Okay. So let's start. Let's begin first of all. So first of all, guys, what I required. So here, basically, I required the data. So see, I'm not going to collect the data from any file or folder. So this thing basically I'm trying to keep it as simple as that, right? So here what I did, I created a corpus. Okay, I created like a corpus of document. Here you can see. So we have like a corpus of the document inside the list. I'm not going to load anything uh, from my txt file, from my PDF, right? So here itself I kept it just for sake of simplicity, right? In my next video, so even I did it. If you will go and check with my live section, so here basically I was trying to read the data from the PDF or from the txt file, or here if you will look into my introduction video or this QA system and all, yes, I'm doing that, right? But here everything basically I want to show you from scratch. So this data part also I want to keep it simple only, right? I hope you are getting my point. Now this is what, guys, this is my corpus of document, right? Document means what? Tell me. Corpus means the entire data, right? Document means what? Document, this particular sentences which is called the document. I hope you are getting my point. Now what I'm doing here, so let me print this corpus of document. Now here you'll find out this is nothing, this is my document, right? Now after that, guys, what I will do, so here guys, see this document, right? What I will do, I will convert into the embeddings, right? Embedding means what? Embedding is nothing, it's a representation, it's a numerical representation, it's a numerical representation of this text, right? We have this text now. So embedding is called the numerical representation of this text. So what I will do, I will keep the data, okay, inside what? Inside my vector store. So here, guys, see, again, I'm saying I'm not going to use any PDF file. I'm not going to use any vector store or anything, right? I will keep it as simple as that. So everything I will keep it here itself in my file, in my variables only, right? But you will get the clear cut idea that how this is working in a backend, right? How this thing basically we can implement like from scratch. Okay, if someone has created the different framework like langchain, llama index, so how the person has written the code and all, everything you will get it over here, right? So what I required, guys, so here actually I required the embedding. So with respect to this particular sentence, I required the embedding, means I required the numbers, okay. So let's try to do that, and let's try to create a number by using these particular sentences, right? And after that, basically we'll try to find out a similarity, right? Similarity between what? Similarity this query, right? Similarity between this query, the query which user is asking, and this document which is stored inside the knowledge base, right? So my knowledge base, my vector databases, whatever you can think, everything is here itself, where in my system. As of now, this is what? This is the nothing, this is just my data, right? Now for the similarity search, what I'm going to use, for the similarity search, I'm going to use the cosine similarity, right? So first of all, what I can do here, I can give you the formula of the cosine similarity also. So let me give you the formula of the cosine similarity. I kept it over here. Let me take a short screenshot of it and let me paste it over here. So already I kept in my document, and I'm just going to copy and paste that particular formula in my notebook. So this is the formula of the cosine similarity. If you want to calculate the cosine similarity, so there you need to, like, there actually you need to multiply two vectors, like two vectors A and B. So here you need to multiply, not multiply, basically it's a dot product. I think you know about the dot product. And then basically we have to divide it by using the magnitude, right? This is what? This is the magnitude of the vector. Getting my point? I think everyone is getting that. It is very, very simple, right? So for similarity search, what I'm going to do, I'm going to use the cosine similarity. Okay. So yes, till here everything is perfect, everything is fine. And if you are liking this video, then please hit the like button, guys. And yes, now to the further implementation, right? So what I want, guys, I want the numerical representation of the data. What I want the numerical representation of the data. So first of all, I can take very simple example and then I will show you the further thing. So here what I'm doing, so let's say here is my query. So user is asking query, so I can write over here user query. So user is asking one query. Let's say the query is very, very simple. Here I can write the query. In the query, basically user is saying, let me give you the specific query over here. So the query is, I'm an Indian, right? And I live in India. So I am an Indian. I'm Indian and I live in India, right? So this is the query which simply user is asking. What is saying? User is saying, I'm an Indian and I live in India. Okay, simple, right? Just a simple like query or simple statement which is being generated by the user itself, right? Now here, document, right? Document means what? So here you can think that document basically it is coming from the data, right? This is just an example which I'm giving you, that I will let you know that I will perform on top of this particular corpus. Getting my point? So here what I'm writing this document, and document means what? Sentence itself, right? So I will perform the similarity search between this query and this document. So that is my main aim over here. That's it, nothing else, right? And then I will ask the relevant queries and all. So from here, from this document itself, this particular document which I kept over here. Now what I'm doing here, so here in the document, what I'm writing, so here I'm writing India. India is a country. India is a country. Okay, for the Indians and for everyone. So everyone else. So this is what? This is my document. This is my main document, and here is what? Here is my user query. You can assume that. Now what I want to find out, I want to find out a similarity between this query and this particular document. Okay, and then I will ask the relevant query. Wait, I will do that, and then I will generate it from the LLM also. And how you can access the LLM in your local, I will show you that also, right? So please watch this video till end, and definitely you will get a great learning from here. Now here, this is my user query and this is my document. Now first of all, guys, if I want to find out a cosine similarity, so I will be required the vector a and b should be what? Should be the vector itself, because I have to perform the dot product now, and then I have to find out the magnitude of it. So here what I'm going to do, I'm going to convert this particular data into the numbers. Here I'm not going to use anything. Again, I'm saying word to bag or OpenAI embedding, or maybe like any other embedding, bot embedding, transform embedding. No, I'm not going to use that. Everything I'm doing from scratch by myself only. Okay, please remember this thing. Now here what I'm doing, so here I'm going to be import few statement, and by using that basically I can generate the numbers, right, with respect to this particular sentence. So here, guys, this is my import statement. So first is what? First is a counter, right, which I'm going to be import from the collection. And the second is what? Second is math, right? Now why I did it, I will let you know now. So here what I'm doing, so here first of all basically I'm going to be write on top of this user query. So user underscore query. Okay, user underscore query. So query. Now here on top of it, I'm going to perform this lower. If anything is not in a lower case, then I'm going to convert into that. And then here I'm going to be split it. So split, right? And split based on what? Based on the spaces. Now once I will write it down here, so here you will get that I'm getting a like list of the tokens, right? Now here the same thing basically I'm going to do by using this document also. So here what I'm doing, I'm going to write this document. Okay, so document is nothing, it's a sentence from the data, from the corpus itself. Now document, and then here you will find out, so this is the like tokens from the document. Here I'm just doing a tokenize, right? So simply I can write here, so this is what? This is my query underscore tokens. Now here this is what? This is my document underscore tokens, document underscore tokens, right? Now I hope it is fine to all of you and everyone is able to get it. Now let me print it, and definitely you will get that how the tokens look like. Now what I will do here, guys, I want numbers. Okay, I want numbers. I want to represent this particular sentences in terms of number. So here what I'm doing, I'm going to count frequency of the, I'm just going to count the frequency of the words, right? For that, what I'm going to do, for counting the frequency, simply I'm passing this particular documents, right, to this counter, right, to this counter method. So here the counter which I imported now over here, to that only. Now here, if I'm going to pass this query underscore tokens, right, tokens. Now here you will find out the frequency, and this frequency basically I can use as a embedding. Okay, I can use as a embedding. Now here what I'm going to do, guys, so here basically I'm going to write this underscore query underscore counter. That's it, right? Now here similar to that I can write for the document also. So here is what, here I'm going to write for the document. Okay, document counter, and here what I'm doing, I'm going to pass this document tokens, document tokens. I hope it is clear to all of you that how to create a tokens. Actually it is nothing, it is giving you just a frequency, right? So see, frequency of the word, that's it, nothing else. Now here if you will look into this document counter, so definitely will get the frequency of the word, that's it. In India, how many time it is coming is country, four is coming 2 time. Okay, so I hope this thing is clear to all of you what you are getting. So with respect to the like sentences, I'm going to be generated tokens, and then I'm going to generate a frequency. This frequency, this the particular number I'm using as a embedding, right? Here I'm not going to use any fancy embedding like TF-IDF or word to bag, or maybe what embedding, or maybe any like OpenAI embedding, Gemini embedding. No, everything I'm keeping it simple and from scratch only. Okay, great. Now here, guys, what I'm going to do, see, now I have to find out the cosine similarity between what, between this particular sentence, right, this sentence and this query. Now how I can do that? So for that, guys, I written a logic. So first of all, let me show you the logic, right? So here what I'm doing, so first of all, guys, I'm going to run the for loop, right, for loop. Now see here, if I'm going to show you the like vector basically, so let me show you the vector, how the vector looks like. So first of all, what I can do, I can write the simple logic here. So let's say this is what, this is my list, right? Now this is what, this is my list. Now here what I can do, I can get the tokens, right, tokens from here, tokens from the query, right? So for in, and here simply I can write underscore query underscore tokens, right, query underscore tokens dot keys. Now here, guys, what I will do, so I will be getting the keys, right? Now let me print this tokens, and definitely will get that. So tokens, and here you can see what I'm getting. I am getting this thing, list object into keys. So here query underscore tokens. Okay, so I think I need to iterate on top of this one, counter. So just wait, let me replace it with a counter, and definitely will get that. So here, see, I am. Now what I can do, I can again call this one, and definitely will get the tokens, right? So here with respect to the tokens, whatever number is there, see, 2211 and all. Now simply I can append inside this one, list dot append, right, list dot append. And here what I can do, I can keep it over here. So see what I'm getting here, I am getting the like vector. So this is what, this is my vector, this one. Okay, so this is what, guys, tell me, this is my vector, my first vector. Okay, with respect to this particular sentence, the first sentence, query, right? Now like this basically I can collect a sentence from the second I can collect the vector from this document as well. Okay, and then I can find out the similarity. Now here, guys, this vector basically which we are generating, this is what, this is a sentence vector. Okay, this is the sentence vector, right? But here, guys, I'm not going to use this sentence vector because I tried with that and I was not finding out that much similarity, right? So here I'm going to use one more logic. This is what, this is a sentence vector, right? Again, I'm explaining you that. So here you can see this is what, this is my user query. Now let me keep it over here, and this vector basically which you can see, this one it is representing to this query. And here this is nothing, tell me, guys, what is this? It's just a frequency, and now here you can see this is what, this is the sentence vector. Now I can generate the sentence vector, from the next document also, and we can find out a cosine similarity between those sentences, right, between those sentence vectors by using this particular formula, right? But here for more like for getting the more similarity, I'm going to use the different logic, right? So here I'm going to match word by word, right? Wherever word is going to be matched now inside the sentence, those number I'm going to take, and I will perform the dot product with respect to that only, right? Once I will write it down, you will get it, right? So here what I'm going to do, I'm going to write the logic, and the logic is going to be a very simple. So let me mention the logic over here. The logic is saying for tokens. Okay, I will collect only those token, right? So here I'm going to find out the word level similarity, right? Word level similarity, and with respect to that only, with respect to that number only, I'm going to do a dot product. Getting my point? I'm going to find out a word level similarity inside the sentence, right? And whatever vector will be generated with respect to that, I'm going to perform a dot product only for those value, right? You will get it. Let me write it down here. So here what I'm doing, so here I'm writing for, right? For what? For tokens. Now here I'm writing in, right? In query, query underscore what? Query underscore counter. So query underscore counter, now coun counter, and from here basically what I'm going to generate, I'm going to generate the keys, right? Now here what I'm writing, so and here I'm writing and here I'm writing query, sorry, document underscore counter, document underscore counter, and from here I'm going to generate the keys, right? And means what? Whenever it's going to be similar, then only I will get the tokens, right? So if I'm going to print it, then definitely will get the value. Let me show you. So here if I'm going to write this tokens, right? So see, India and basically, okay. So if you will look into this particular sentence, so here actually you will find out in these two sentences, India and is two similar word, right? India or and, right? India and this and, actually there is two similar word, right? So I'm going to generate an embedding related to this two similar word only, and with respect to that only I will perform the dot product, and I will try to find out a cosine similarity instead of using this sentence vector, because it was misleading to me, the complete sentence vector. For that, this counter approach is not a good one, means counting approach. For that, maybe we'll have to use the sentence transformer or OpenAI embedding, or maybe Gemini embedding, right? But here counter approach, basically I'm not going to use the entire sentences, it might mislead to me. That's why I'm using the word level similarity over here. Okay, now what I'm doing here, so this is fine. Now what I will do, I want the numbers with respect to this two thing, right? I want number. So how I can do that? So simply I can create a list over here. So here I'm writing this my list, and here what I'm going to do, I'm going to append inside the my list. So my list dot append, and here what I'm going to do, here I'm going to write this query counter, right? Query counter multiply document counter, right? So query counter here is what? Query counter, and multiply what? Multiply with this one, document counter. So let me write it down over here. Multiply with what? Multiply with the document counter. So let me take this document counter, and here I'm going to paste it, right? So here is what? Here is going to my tokens. I'm going to perform the dot product now. So in dot product, what we do? Tell me. First we multiply and then we'll add it. That's it, right? So here what I'm going to do now, I'm going to run it, and here basically we'll find out. Let me show you this my list. So here actually I have this my list, right? What I'm doing, so query counter, right, and document counter. From here basically whatever, see here I'm getting two words. If I will show you, let me show you, let me run it over here. So here actually you will find out two words, right? So first is what? Let me print it. Let me print what? Let me print this tokens. Okay, tokens. Now here actually you'll find out the India and this and. So with respect to the India, you can see one. Okay, one is going to be multiplied with what? One. Okay, sorry, one. So I will be getting. So here I will be getting one. Now here the second word is what? And, right? And. So and is going to be multiplied with what? And. Okay, so and is here, right? And is going to be multiplied with and. So one multiplied with one, it's equal to one. So I'm using this vector only instead of this vector. Instead of using the sentence vector, I'm using this vector, where I'm having word level similarity between what? Between the query and the document, right? So it will give me a correct result instead of this one, I hope you are getting my logic. Yes or no, right? So here actually why we are doing this multiply, tell me? Because we are going to perform the dot product now. You know the dot product, how to perform the dot product. Let me show you the dot product also. So let's say we have one vector. So here is what? Here is my one vector, right? So let's say this is what? Here I am having India, and India is one, and is one, right? This one, this two word is similar now in both like counter, right? So India is one, and is one, right? Now here what I will do, I will collect the one from here. So one is here, one is here. Now here is also one is here, one is here. Now what I will do, one multiply one. Okay, and here is what? One multiply one plus one multiply one. So if I'm going to be solve it, then what I will get, 1 plus 1 is equal to 2. So this is what? This is my dot product. Okay, now here which thing is remaining? So here sum is remaining. So here what I'm going to do, I'm going to perform the sum. That's it. So what I'm getting, I'm getting my dot product. So what I'm getting, guys, here, tell me, I'm getting a dot product. So this two, actually here you can see right hand side and left hand side. Here what I'm getting, I'm getting two. So this is what, this is my dot product. I hope this thing's part is clear. Now what I can do, I can find out the magnitude, right? So I'm done with the I'm done with this a and b. A dot product with v. Now I'm going to try to find out the magnitude. So here the magnitude is very, very simple. I think you know how to find out the magnitude of the vector basically. So copy and paste the let me directly copy and paste the logic, and definitely by seeing that you can understand. So here if we are talking about the magnitude of the vector, so let's say here is what, here is my vector, this one, this is my vector, this one. I think you are able to see the sentence vector, right? So what I will do over here, first I will perform the square of it, right? Square of this particular vector. So 2 square plus 1 square plus 1 square plus 1 square plus 1 square, something like this. And then basically what I will do, I will add it, and finally I will find out the square root of it. That's it. That's the magnitude. I think you know about it, right? So here, don't worry, in my embedding chapter, I will start one embedding chapter also. In that basically I will tell you, let's say this is what, this is my vector. Now if I want to find out a vector of if I want to find out the magnitude of it, so let's say a and b. So how to find out the magnitude? Tell me. A square plus b square, like this, na? Okay, the same thing basically I'm going to implement over here. That's it, nothing else. So this is my vector, and now let's try to find out the magnitude of it. So here I written a simple logic for getting the magnitude. So let me show you and let me run it. So this is the, like, first we are going to collect all the tokens. Okay, so from the tokens basically I'm going to extract the value, then I'm doing a square, and then finally sum, and then a square root. That's it. So here what I will be getting, I'll be getting my query magnitude. So this is what, this is my query magnitude. Now what I will do, I will collect my basically document magnitude also. So here is what, here is my document magnitude, guys, this one. So this is what, this is my document magnitude, and here we are going to collect the tokens from the document, and then finally sum it, and then square it. Simple logic, nothing else, right? So here is what, this is what, this is my document magnitude. So I hope it is clear to all of you, query magnitude and document magnitude. Now if I want to find out a similarity between what, between this, tell me, between this user query and document. Now easily we can do that. Cosine similarity formula is ready, right? So what is the similarity, guys? So here let me write it down. This is what, this is my dot product, dot underscore product. Okay, and here is what, here is my similarity. That means here is what, here is my magnitude. Now let's try to form the formula for the similarity. So similarity. Now what I will do here, so here I'm going to write this query, sorry, here I'm going to write this dot product, dot underscore product, divided by what, divided by this query magnitude, query magnitude, multiply with what, multiply with this document magnitude. That's it, nothing else. So multiply with what, multiply with this document magnitude. I hope it is clear to all of you. Yes or no? Yes, right? Now if I will run it, guys, so here I will find out the similarity between these two sentences. Now here you can see the similarity 0.17. Okay, now you can check the similarity with any other sentences, anything, right? So here let's say, let's try to generate a new query and the new document. So here I'm saying, here I'm asking, is yoga, right? So here I'm asking, is yoga good, good for health, HEAL PH, right? So here I'm writing the document, yoga is very good. So yoga is very good, good for living, for living healthy, HEALTHY, healthy lifestyle. So healthy lifestyle, right? Style. And okay, so this is what, this is my sentence. Now here what I'm doing, I'm running it, and now basically what I can do, I can again execute it. So this entire one, and definitely you can find out the similarity between that, right? You can find out a similarity. So what I did, guys, instead of running it again, I created one method for all of you, right? And with that, definitely we can check it again and again. Like, no need to write it down the same thing now. So let me give you this particular method, and definitely we can check it by using this particular method. So here is what, here is my method, cosine similarity, and the same thing I written inside the method itself, nothing else, right? Now what I'm doing here, now I'm just going to call this cosine similarity. So let me remove it, cosine similarity, and here what I'm doing, I'm going to call this particular method cosine similarity, and let's try to find it out. So here what I'm doing, I'm passing this query, okay, user query. Now here is what, here is my user query, and what I will do, I'm going to pass this particular document, right? This particular document. Now see guys, I created the formula, right? So 0.6, this is the cosine similarity between this particular like query and this document. So by ourselves only, okay, manually we have created this cosine similarity formula. Now guys, see, here knowledge base. So we have a document. Okay, this is the document. Now let me show you, and then I will implement the further thing over here. I will call the language model. So here is what, here is my document, means this is the document. Now here chunking and all, everything is done. Embedding, basically we are going to perform the counter operation, right? Counter operation. And here we are not going to keep it inside the knowledge base. It is fine as of now. We are not going to create any sort of indexes and all. It is fine, right? So our embedding is ready. So here my embedding is ready, and it is in my variable itself, it is in my file itself, right? You can assume that because it's a simple architecture. Now here what is happening, so here actually we are going to perform the, here what we are doing, tell me. Here we are going to perform the query similarity by using the cosine similarity, right? So now let me show you how it is happening. So whenever user is asking any query, so I written the queries now. Whenever user is asking any sort of a query, so here this query basically is going to be convert into the embedding. I think we know about it. We are going to call the counter, and then it is going to find out the similarity search, right? Similarity search. And after that basically we'll find out the similar result. Okay, similar result, right? I'm not going to rank the result and all. I'm just going to find out the similar result. What will be the similar result? And then this particular result I'm going to pass through the LLM. Getting my point? So here guys, here at this place, see, let me again give you the idea. So what we are doing, see, here actually this is what, this is my embedding. Here I'm keeping my all the embedding with respect to the sentence. Here whenever user is asking something, so it is going over here, it is converting into the embedding, which is nothing, which is the counter itself. And here basically what we are going to do, we are going to find out the cosine similarity. After cosine similarity, basically I will find out the relevant document, right? Relevant document. So here basically I will find out the rank result and all. Okay, I will show you how. For that also I've written a method, right? And then we'll pass this particular thing from the LLM itself. So now let's try to implement this particular functionality. So here for that, what I did, so here actually I have created one more, method. So let me keep that particular method over here, and then finally I will show you the LLM part. So here is what guys, here is my method. So my method is what, return response. So here I will pass my query, and here is going to be my corpus, right? So similarity, basically I'm going to be collect over here with respect to all the corpus, means this is my all the corpus means this one, all the documents inside the corpus, this one, right? And then one by one basically I will calculate the similarity over here. One by one I will calculate the similarity. So let me call this method cosine similarity. This is the method. And then I'm going to collect all the similarity, right? I'm going to append that, and then I'm going to return. Okay, what I'm going to return, which document I'm going to return, wherever I am having a max similarity, right? So here similarity dot index, now here is wherever I am having a max similarity, right? Wherever I'm having a max similarity, I'm going to return that particular document. Getting my point? I hope you are getting. Again, let me show you. So here basically this is the empty list, similarity list. Now here I'm going to match the similarity with respect to each and every document, whatever document is there, right? Whatever document is there inside the corpus, right? With respect to this query, and I'm going to return the relevant one. Okay, I'm going to return the relevant answer. I can return the multiple result, or I can return the one result. It is up to me. So here I'm going to here I'm going to return the, here I'm going to return with the max similarity, right? So this is my method. Now this two method is ready. Now guys, here you can ask any sort of a thing. So just look into the document here, that basically whatever corpus of the document which I kept over here. So let me print it, and based on that basically we are going to ask the query. So here we have a different document. So now here I'm asking something. So here basically let's say my query is what, so my query, user underscore query. Here I am asking, or query, basically simply query I can write here as of now. So here I'm saying I like fresh air. Let's say based on that what I will be getting from the document. Okay, let's say based on that what I will be getting from the document. This is my document and this is my query. Okay, and here is two method, return response, and this is what, this is the similarity one. This is the cosine similarity, right? Now what I'm doing here, I'm going to call this particular method return response. So once I will call this method return response, so first of all I will have to pass the query over here, and here I'm going to pass my complete document. Okay, everything embedding and all, everything is happening over here itself, right? I've written the counter and all over here itself, right? Now what I'm doing, so here I'm passing this query and corpus of document. So see, here it is saying take a legendary walk in the park, enjoy the fresh air. Getting my point? Now let's say here I'm asking again, I'm asking the query. So I like to do yoga, right? So here I'm asking the query, I like to do yoga. Now let's see which is going to be a relevant sentence from here, from this particular document, right? So here what I'm doing, I'm going to pass the query along with the corpus of document, and let's see which is going to be a relevant document, right? So let me search it, and here you can see, so here it is saying take a yoga class and stretch your body and mind. Getting my point, guys, here? So here we have created our retrieval system, and now what we are going to do, see here what I did. So here I'm going to rank the result, the top similarity result. I can rank the multiple result also, 5, 6, 7, 8. It is up to me, right? Now I'm going to generate that particular response from where? From the LLM. Now let me show you how you can configure this LLM inside your local system. So what I can do here, so here actually, let's see how how you can configure LLM, large language model, in your local system. So here guys, what I'm going to do, I'm going to use the llama. Okay, it's the open source model. I'm not going to use any other model, right? So like Gemini or OpenAI GPT or this one, like other models now, Cloud A, or maybe Jurassic, right? Many more models we have for the generation and all. Now simply I'm using this Llama 2. How we can do that? How we can do that? How we can utilize, or how we can do the setup in our local system? So here one option we have, that is called Hugging Face. So by using the Hugging Face pre-trained model, I can download this model here in my system, or I can use the Hugging Face API also, but we are not going to use. So we are not going to use this one, right? So here I have one more way for using it, and the way basically which is called OLlama, right? OLlama. Let me show you what is this OLlama. So once you will search about this OLlama, right? So here you will get this particular website. Now just click on it, just open it, and see over here what it is saying. So get up and running with large language model locally, right? So here you can use this Llama model locally, right? Llama model locally. Okay, you can do the fine tuning, basically just for asking the query. As of now we are doing that. Fine tuning part I will show you later on. Now simply you can download it from here. Once you will click on this download, you will get the multiple option. So Mac OS, Linux, Windows, right? If you don't know about the Llama, guys, it's a metal of the it's a model of the Meta, right? Let me show you the Meta website. So there basically you will get that. So here you can see discover the power of Llama. You can go and check with the complete detail of the Llama. From here also you can download the models, right? But here we are using the inbuilt setup. I will show you how useful it is, this one. For that you just need to download it according to the set system, right? Now guys, after downloading it, what you will do, tell me. See, once you will done now, then after downloading it you will get something like this. Let me show you what you will get. So you will get the llama OLlama inside your system, inside your download. So this one, okay, OLlama setup, this one. So just click on it and try to set up it. That's it. After that, okay, see, again I'm saying I did it already. You need to double click on it and just let it download, let it install inside your system, right? And after that, what you need to do, you need to open your cmd. Okay, now over the cmd, guys, what you need to do here, let me show you. So once you will open the cmd, right? So over the cmd means what? Command prompt. Now over the cmd you need to run this particular command. The command is what? The command is O llama run llama 2, right? Simple. So once you will run it, guys, automatically the llama will be the llama model will be configured, and here you can see you can ask any sort of a query to your llama model. Automatically it will be configured. No need to do anything, no need to set up any API or anything. Just try to download that package and install it and call the llama over here. Now you can ask anything. So let's say here you can ask to your llama, okay, I like blue color. What is the color of sky? What is a color of sky. So here any query, random query I'm asking, that's it. So if I will hit enter, so here you will see the color of the sky can depend on the atmosphere. Can I see? I am getting a response from my Llama 2 model. Llama 2 model. Now, if you want to quit it, so here simply you can write this by and see it's getting quit. Now here guys, what I need to do, I need to call this Llama model from where? From my Jupyter, right? From my Jupyter. So over here guys, see, you will find out the complete detail. Let me show you that particular detail also. So here let me show you one page, and here actually by using this particular page you can get the complete details. So see, download and all, everything basically you will get. Now code llama, just click on it. Now here you will get the complete detail with respect to this llama and all, right? CLI, then how you can call it. So by default actually, by default whenever you are running this command na, OLlama run code llama, or OLlama run llama2, that's it, right? So by default it is running on this particular URL, this one, this particular URL. So I have to call this URL. Right? Now let me do it over here. So here what I'm doing, now see, it is a generic response. It's a cosine similarity, but I want to augment this response. What I want to do, I want to augment this response. So here let me write, I want to augment this response. I want to augment this response by using what? By using llama 2 model. Now how I can do that, how I can augment the response by using this llama 2 model. So here simply guys, I written one one method, sorry, one code, and with that basically definitely you will get to know. So see guys, this is the code, and I just written it by myself, just by using some modifications and all, doing some modification and all, and definitely you get it. So here is what, here is my prompt, right? So in the prompt basically, just focus in the prompt what I'm saying. So I'm saying you are a bot that makes recommendation for activities, right? Based on what? Based on my sentences. Here is what, here is the activities related to the different thing, right? Different activities basically based on the interest and all. Now here I'm saying you are a bot that makes recommendation for the activity. You answer in very short sentence and do not so here you can see the complete prompt, and do not, right, and do not include extra information. So this is the like prompt we are passing to our LM model. So this is the recommended activity. So here I will pass the relevant document, means this particular answer, this one, and based on that, this is the user input, and then basically I will generate the complete sentence. You see, you can modify the prompt and all according to you, whatever information you want to generate from the LLM. So here I want to augment this particular information. So here I am passing the relevant document, means this is the similar document, okay, based on this particular query, and according to that this llama 2 will generate the answer for me. Okay, now here you can see this is my prompt. Now I told you that by default actually it is running on this particular URL. Whenever you are executing this particular command, now whenever you are executing this command, let me show you which command, this one, OLlama run llama. So by default it is running in this particular URL, right, in your local system, okay. Now here what I need to do, here actually I'm, see, it is running, okay, it is running on this URL. Now I have to request to this URL. Now here some web related concept comes into the picture. So here I have to request to this URL. I am requesting in a JSON form, right? So here is my llama, and here is my model, and here is my prompt. Okay, prompt you can see. So prompt format, now prompt format with what? So user input is here and relevant document is there. If you don't know about the prompt format, if you don't know about guys this like langchain, llama index, right, like how to design the prompt, and don't worry, you will get to know that. But as of now, just think, we are like formatting the prompt along with this relevant document and this input, basically user input, right? And based on that we are going to generate a response from the llama, that's it. Now what I'm doing here, so here is what, here is my configuration. So the request basically which I'm going to be make, if you are aware about the web concept, right? So how to make a request and response, post request, get request, right? So definitely you will be getting this part. So here is my header, so I'm configuring the request. Now here I will hitting the, here I'm making the request, right? So request dot post, here I'm passing URL, here I'm passing the data in the form of JSON. Here is my header, streaming means true, means you need to generate the answer, okay, in a single shot. No need to provide the answer, you need to generate the answer, that is the main aim. Then I will be getting a response, and here I'm iterating on top of the response, and I'm decoding over here, that's it, right? And I'm keeping inside this particular list full response. So let me do one thing. Let me create the list over here after importing several libraries, because here what I'm doing, I'm hitting to my llama which is running on this particular URL, guys, please understand. Okay, now here is what, here I'm getting the full response after decoding this particular thing, and here's finally I'm going to be close this response, and this is my final response. Let's see whether it's going to work or not. Okay, so here simply if I'm asking, simply if I'm, this is my query, I like fresh here, this is my query. Now I'm going to check the relevant document over here, right? So here, what I'm doing, I'm running it. So here you can see, take a leisurely walk in the park and enjoy the fresh air. So here is what, here is my relevant document, right? Document. So document. Now here what I'm doing, so let me take let me check the correct is, this is the correct spelling or not. So here I can keep it over here. Okay, now let me run it, and yes, this is what, this is my relevant document, and this is what, this is my query. Now what I'm doing, I'm passing this particular thing to the llama. Let's see what will be happening here. So here if I'm passing it, guys, let's see whether I will be able to get it or not. Here is saying user input is not defined. User input. Okay, so this query is going to be a user input. Let me change the name over here. So it's going to be a user underscore input, and let's see whether it is working or not. So I'm hitting to my LLM, guys, and see it is working or not. I'm passing my llama, I'm passing to my llama 2 model along with this prompt where I'm having this query and this relevant document. And let's see, guys. So see, so here I'm getting the output. Great, based on your interest in fresh air, I recommend taking a leisurely walk in the park. It's a great way to enjoy the outdoor and get some exercise while breathing in the fresh air. See, guys, see, right? So we have created our own augmented system, right, from scratch without using anything. Now let me ask something over here, something else. So I like to do yoga. So this is what, this is my user input. Now if I'm going to run it, now here is what, here is my relevant document basically, which I'm going to be collect over here. Now see here, basically in the relevant document what I will be getting. So let me check what will be the answer. So the answer is take a walk in the fresh air. Okay, so here is what, here is a user input. Now let me pass this user input over here, and I will be getting the output relevant document. Now yes, this is my relevant document. Now here I'm passing this one. So let's see what will be the generation of the, what I will get from the llama, right? And then finally I will show you the architecture. See, so based on your interest in fresh air, I recommend take a part. It's a great way to enjoy outdoor. Okay, great, based on your interest in yoga, I recommend. So it is combining the information over here, right? It is like combining the information over here, and here you can see it is talking about the yoga now. Getting my point, guys? Yes or no? Because see why it is combining, because full response was there, I haven't initialized this full response. Now if I'm going to initialize it again, so it won't combine. Now see, you will get the fresh output over here, so related to the yoga only. Now see, great, based on your interest yoga, I recommend taking a yoga class. Before it was like combining the output, because I haven't initialized this list again. So I hope this is fine to all of you. Now we have created our own system. Now again, let me go back to the architecture and let me give you the quick overview. And then finally we'll conclude the session. So we have the document, guys, and here, this is my document. So this document, basically I'm here, basically what I have an embedding of the document. Now user is asking something. So here it is searching the cosine similarity. And then here I'm getting a relevant document and the answer. Okay, I'm not giving the answer user directly. No, I'm passing it through the LLM for augmenting it, for enhancing it. I hope you got this particular session. So please try to do it by yourself. And yes, if you're liking the video, guys, then please hit the like button, and please try to run it, this llama. Okay, this particular command, once you will run it, definitely will be able to run the llama 2 model inside your local system. You just need to download it and you just need to install it, and then run this particular command. Automatically it will be configured, and then you can ask any sort of a query, right? Fine, guys, thank you very much for watching this session. We'll meet in the next session soon. Thank you, bye bye, take care.